Let's take a look at some of the settings that can help us maximize performance of a virtual machine. We talked a little bit about the memory. Now, typically what we're going to want to do is oversubscribe the memory in the host on the assumption that not all the virtual machines are really going to use it all at the same time. The hope is for a perfect consolidation ratio that all of our workloads are completely synchronized to the point that no two workloads are ever really used at the same time, or that they're not depending on common resources at the same time. Of course, we know that that's not always true. So one of the problems that we potentially run into is that if I don't subscribe enough memory, the VM won't be able to take advantage of it. If I subscribe too much memory, then VMware may be wasting memory on me that I'm not really using. So VMware has some very interesting architectural tricks, such as the balloon driver, that can push memory into the operating system page file of the guests by creating fake memory requests. And it can help reclaim some of that unused memory that machines don't really need that's accumulated in memory because the virtual machine thinks it has lots of memory. Potentially we could set some very large memory amounts, but we should try not to oversubscribe to a ridiculous degree. But a little bit of extra memory would not necessarily be a big problem. And of course we have paging within Windows and also swap within VMware that can help us deal with those potential problems. On the CPU side, it's actually really a good idea to minimize the number of CPUs associated with a virtual machine. The symmetric portion of symmetric multiprocessing on the Intel architecture means that the CPU cores need to be somewhat in sync with each other. So having multiple CPUs makes a little bit more of a challenge because VMware has to coordinate all of those virtual sockets simultaneously. This may cause either more delays or at least more competition to the physical CPU cores. Reduce the number of sockets and cores that you have, but reducing the number of sockets may bring you a licensing benefit. But the total number, really, we want to try and keep as low as possible. I like creating virtual machines with 2, but rarely would I go above that. Although you could go quite large if that's supported on your host. Here you can see that I don't have very many choices because I don't have much in the way of CPUs on my ESXi host, but potentially we could push this as high as 32. If we go into the Resources tab, you'll see that what we have here are some resource allocation settings. I might have said that this virtual machine has one virtual CPU. One virtual core can only be used with one physical core at a time. So I can never use more than the capacity of one core. And if I have more virtual cores than I have physical cores, at some point there's a very good chance that 2 virtual cores are going to be competing to access that physical core, and only one can at a time. Hyper-threading allows you to run 2 threads at the same time on one core, but the types of functions that VMware uses, you might find that it doesn't do that very well. It is hyper-threading aware. It's also NUMA aware. If you have systems with large numbers of CPUs, memory can actually be allocated to banks of cores. But still, it doesn't give any guarantee as to how much memory or how much CPU is going to be available. So if we want to do that, we can go into the virtual machine properties and we can set a reservation and or a limit. For example, if I want this machine to always have a minimum of 1000 megahertz of CPU, that means VMware is going to, whether this virtual machine needs it or not, set aside that number of cycles to provide that virtual machine with that amount. And if it can't provide those resources, it's not going to allow virtual machines to be started. Either this or other virtual machines that try to reserve those resources won't be allowed to be started. So a reservation is a hard floor. This is the least amount of CPU that this virtual machine will ever get. A limit, however, is a little different. So what I could do with a limit is say, well, I want them to have guaranteed 1000 megahertz of CPU at all times, but I never want them to have more than 2000 megahertz of CPU at any given time. We get to play within our reservation and limit. If there's more CPU time available than 1000 megahertz, VMware will give that to the VM if it needs it, but in this case, up to a maximum of 2000 megahertz. You probably don't really want to be micro-tuning this in most environments. If you have 4 or 5 virtual machines, I guess it's not so bad, but in a large environment, we're not really going to want to do that, and we're not going to want to have to recalculate these factors. Every time we add new virtual machines, it's going to change the calculus. What we could do here is instead of using reservations and limits, you may find that it's better, and typically is better, to use what are called shares. Instead of specifying an exact hard floor or hard ceiling for CPU resources in this case, we can say that this virtual machine has a high share. Well, what does that really mean? Well, it's going to be a comparison of the shares of the other virtual machines that are running. So if I have 2 virtual machines and one is running at normal shares and the other is running at high shares, If they don't need the CPU time, they're not going to get it. They're not going to take it. If the other virtual machine with a lower set of shares needs more of that CPU time and it's available and the other VM doesn't need it, it will get it. But when competition starts to occur, when VMware is not able to provide capacity to both of those machines, then the machine with the higher shares will get a higher priority. Normal is twice as many shares as low, and high is twice as many shares as normal. Also enter some custom numbers here. We need to be thinking in terms of a load factor. So what's the share setting for CPUs on all the other virtual machines taken as a whole and then divided up as per the number of virtual machines and so on? That will give us a weighted average and will give us an idea as to how the resources will actually get allocated. I'm just going to return this back to normal. We can do the same sorts of things with memory as well, and we can reserve a specific amount of memory. We can limit a specific amount of memory. You never use more memory for a virtual machine than what's declared in the virtual machine properties. If you don't need to provide it to that virtual machine, maybe you shouldn't, and maybe you should say 2 gigs of RAM instead of 8. Now, there are ways like the balloon driver to reclaim some of that memory, but again, better not to declare it if it's not going to be used. However, we talked a little bit about being able to hot add memory in one of the videos. We can't hot remove memory, although we saw we could, on some hardware, hot remove CPUs. So what we may want to do is, if we have memory amounts that are changing, and I want to adapt these more dynamically than I could using the settings, maybe then I want to use reservation and limits on memory. Even if I set the declared memory for a virtual machine, that's not a reservation at all. So we can use reservations to guarantee that that memory will be available, and we can also use limits to specify that we temporarily want to reduce the amount of actual physical RAM that we want that machine to see. The machine's still going to see the same amount of declared RAM. It's not going to be backed up by physical memory though. And it's either going to go to the VMware host swap, or if VMware is capable, it's going to use the balloon driver to trick the virtual machine into using its own swap to give up memory for the balloon driver, which VMware then doesn't actually honor with any physical backing memory. So we can do that for CPU, we can do that for memory, and those are really under the absolute direct control of VMware and VM kernels. When it gets to disk and network, it's more difficult because there's mechanical issues and delays and latency on the SAN or iSCSI or whatever it is that we're using for our storage. So you'll see on disks, we don't really have exactly the same options. We can limit the amount of demand that we're placing on that data store. We can limit the number of I/O operations per second, but we can't guarantee the number of I/O operations per second, at least not here. Potentially, you can use storage QoS if your storage supports it and your version of VMware supports it. And again, you see we also have a shares option here. So we could specify that this virtual machine has a higher or lower priority or standard priority for access to the disks. And you also can see that if the virtual machine has multiple disks, we can actually change those and set what the priorities for the different disks are. And maybe the data disk has a higher priority than the system disk. And you can also specify whether to do core sharing or not. Generally, you're not going to want to mess with this, but typically whether we should share physical CPU cores when the host supports hyperthreading. This helps us to avoid the problem of waiting for multiple CPUs to all be ready at the same time. A lot of people do like creating their virtual machines with 2 virtual CPUs. As I said, not necessarily a bad idea, but can cause you some difficulties when it comes time to CPU schedule. When we have large numbers of virtual machines, or at least large numbers of virtual cores compared to the physical cores. So what we can do in those types of cases is we can specify that we want to keep at least virtual machines with 2 virtual CPUs on the same physical core and actually just back those 2 up through hypersharing. You can do these kinds of things and specify whether to share virtual cores or not. You can also associate this virtual machine with specific physical CPUs, or at least their cores. In the end, there's no real benefit to doing it. Now, inside of the virtual machines, there's also a fair amount that can be done for optimizing network and disk performance by changing the types of drivers that you're using. So we're going to take a look at that in the next video, where we're going to use the PV-SCSI and the VMX network driver to optimize performance under heavier load.